problem today. We're going to start concept 31. It's called end behavior. Now, it's extremely important that you remember that it's called end behavior, because when we go over these examples, you have to remember to look at the end of the graph. Okay, the end of the graph. So let's start. This thing called infinity notation. Do you remember when we looked at domain and range?
Yeah.
And we said like negative infinity to infinity, all that stuff?
Yeah.
It's going to come up again, those terms. Okay, it's a different topic, but it will come up again. Now, here's what this means before we start going over all of this stuff. The process today is the following. If you're given a graph, any graph whatsoever, we want to be able to describe what happens at the end of the graph. At the end, at the end of the graph. Now, if you had a graph that looked like this, let's say the graph went up, flattened out, back down, back up, flattened, and then up like this. If we want to figure out what happens at the end of the graph, we have to discuss with infinity notation.
Why is it saying you're giving me that? Why is it giving me that?
So, for this graph, on the left side, the end of it goes down. On the right side, the end of it goes up. Is everybody clear with that? Look at the ends. I don't care about the middle, ignore anything in the middle. The end of this side goes down, the end of this side goes up. That's what today's lesson is all about. Now, it can be a little bit confusing because of the notation we're going to use. Because we're going to use infinity notation. So what I need to do first is give you some guidelines on how to do this. So, what I want to know is, as x goes to infinity, what happens to y? Now, what does it mean about x going to infinity? What does that mean?
It never stops.
It never stops. It goes on and on. Good. Now, the x-axis. Which way is the x-axis drawn? What is the word for that? Horizontal is the word. You all did the right notation, but the word is horizontal. Y is vertical. Now, as x goes to infinity, we're talking about what happens as the graph goes to the right. So as x goes to infinity, we're talking about to the right. If we're wondering what happens as it goes to the left, we say as x goes to negative infinity. That's what to the left means. So we have to start by defining that right away. Now, we want to know, does the graph go up or does it go down? Now, in terms of y, if I go up forever, what is that called? In y terms.
Infinity.
If I go down forever, what is it called? Negative infinity, okay? So we're good. So up is infinity, down is negative infinity. To the right is infinity, to the left is negative infinity. But in this direction it's x, in this direction it's y. Okay. Now, if I want to write that, I want to think about the word up, the word down, the word right, and the word left. So for each of these, up again is y going to infinity, down is when y goes to negative infinity. Right is when x goes to infinity, left is when x goes to negative infinity. Okay, so what we're going to do in the beginning here today is look at a few different graphs and make some solutions. We'll come up with some answers that we can then use to make a generalization about all graphs. So we're going to look at a lot of examples first, and then we're going to make a conclusion that is based on the evidence that we looked at. So here, we want to know, again, what happens to the graph on either end. That's the goal for today. What happens on either end? Okay? You can write down these four if you like. Don't worry about the example up here just yet, because we're going to go into examples in a second. If you want to write down these four words, you can. They're already here, though. Right is here. Up is right here. Down is right here. Left is right here. Okay? Let's start with the first example of a linear function. So looking at our first set of examples, you have these on your page already. What we want to do here is think about what happens to this graph. Okay, what happens to the graph? Now, looking at the graph over here, so the first graph, let's look at the first example. Looking at the first example, as we go to the left, so start in the middle somewhere. Think about starting like right around here. If I go to the left and I want to stay on the graph or I want to stay on the function, do I have to go up or do I have to go down?
Down.
I have to go down because clearly here's the function down here. So as I go to the left, I go down. Okay? So in your mind, think as you go left, you go down. That's the first thing I want to think about. Next, as I go to the right for this graph, where do I go? You go up. Again, the same graph. As I go to the right, I go up. So to the right is telling me to go up. With that said, we want to make that clear with infinity notation. Now, this part right here, as x goes to infinity, what did we say that meant? To the right. Again, As x goes to infinity means to the right. Well, what happened as we went to the right? The graph went up. So we call that infinity still. Again, as x goes to the right, or as x goes to infinity, y goes to infinity. So as x goes to the right, y goes up. Now, for the next part, it says as x goes to negative infinity, what happens? What happens to it as x goes to negative?
Negative.
Very good. It goes down. So it goes to negative infinity. Okay, it goes to negative infinity. Okay. Now you're probably wondering, what is this LC in degree thing over here? Okay? That's the next thing you want to fill in. We're going to fill in these blanks for the leading coefficient. LC is leading coefficient. Now, the leading coefficient simply means the following. The number in the very beginning. So whatever the coefficient is of the first term, assuming it's in the correct order. Remember, it's got to be in the right order with this stuff. So here, what is the leading coefficient of this one? 2. Very good, because there's the 2 right there. On this side, what would the leading coefficient be?
Negative 2.
Negative 2. Okay, we clear about that? Again, it's the first number. If there's no number there, if it just said x minus 1, what's really in front of the x?
1.
A 1. Okay, keep that in mind. So the leading coefficient here is 2. The one over here would be negative 2. We'll get to the one on the right in a second. Now, what I want you to do in parentheses for the leading coefficient is simply write down if it's positive or negative. And clearly this one is positive. And this one is
negative.
So just note that. We're going to note that every time.
Is it okay if you like? Is it okay like with a positive sign?
Yes, that's fine. If there's no exponent here, what is the exponent really?
1.
There's really a 1 right here, okay? There's really a 1 right here. The degree is the highest exponent. That's all it is. So the highest exponent is a 1 in this one. And we're going to write down whether it's odd or even. We look at the exponent. When you see an x by itself, there's really x to the 1. That's what it really means. Remember, Emmanuel, if you see x squared, then it would be 2.
Whoa, how'd you get 1?
But if there's no, whenever there's no exponent there, there's really a 1 there.
Oh, that's
Okay? So here the degree is 1 also, and it's still odd. So underneath leading coefficient, I want to write down whether it's positive or negative. Underneath degree, I want to write down whether it's odd or even. Okay? And we're not going to use this information just yet. Maybe toward the end we'll use it. Not maybe, we will. But toward the end of the class, we're going to use that. So for now, we're just writing that down. Let's do this one now, though, for the infinity notation part. As I go to the right, do I have to go down or up?
Down.
Down. Be careful. Okay, we're on this side. As I go to the right, I go down. So as I go to the right, I have to go down. Next. As I go to the left, I have to go up. As you go to the left, that's what that says right there, you go up. Hey.
So what are these graphs called?
This is a linear function because it's a line, but what we're focusing on is not what the graphs are called, but the end behavior. This terminology right here. We're going to use it. We're going to use it in the next few concepts. Remember our lesson yesterday we learned the table? And I was like, wait a little while, we're going to use it more and more. Same thing with this. Okay, we're learning skills right now that we can use later. It's going to help us graph these functions. Okay? Go to the next set of examples, please. Now, what are these shapes called?
Parabola.
Louder? Parabolas, good. Or a quadratic function. The function is called quadratic. The shape is called a parabola. Notice for this one, what do both ends do on these kinds? They either both go up or they both go down. Okay? So here, they both go up on the ends. Here, they both go down on the ends. So, as I go to the left, it goes up. As I go to the right, it goes up. So these will both be infinities. Again, if I go to the left, I have to go up. If I go to the right, I still go up. What's the LC for this one? 3 and positive. Very good. 3 positive. 2 and even. There he is. Very good. Degree is the highest exponent. So look at the equation. Highest exponent is a 2 right here. That's your degree. The leading coefficient is always the number in the front. Remember, it's got to be in the right order. All these functions I gave you today are in the right order. If you're practicing this for your homework, some of them I just mixed up on purpose. So make sure you put it in the right order and then do this problem. Here, on the left side, or on the right side over here now. Okay, let's look at this one. What is the value here? As I go to the left, I have to go down. As I go to the right, I go down. So they're both? Very good. Leading coefficient?
1, -1.
-1. Remember, there's a negative in the front, which means we put negative. Degree?
2, even.
Okay, we're on a roll. Good job. All right, we're going to do one more set of examples, then we'll start to make some generalizations or conclusions. What is a generalization? Ooh, what's a generalization here? What does that mean, guys? What is it? Something that applies to everything. Very good. So, if I were to make a generalization that said, oh gosh, there's some very mean generalizations people can make. Nice.
Just say a mean one.
No, I'm not going to say
I mean, it's just, we're not going to take it as this.
Exactly.
I don't care about the recording. I'm trying to.
Ooh.
All right, here's a generalization, and I won't be making fun of any of you guys. Have you heard the saying, "White men can't jump"? Yeah. It's a movie. White men can't jump. Have you seen it? Okay, with Woody Harrelson, really good movie. That's a generalization. That's not really true. I mean, you see, maybe in the NBA there are not as many white people as there are black people, right? In the NBA generally, so that generalization could be true. But white men can't jump would be a false generalization. Some can. Now, what we're going to do is make a generalization about men. So something that applies to all functions. Okay? So we're going to make a true generalization. So in a minute we're going to do that. So let's look at the next example. Here, we have some cubic functions now. It's hurting Emmanuel, obviously. Not Emmanuel, William over here. Sorry, Emmanuel. So we have...
Sorry, William.
You're the one that said, ooh.
No, it's because, no, it's, he called me Emmanuel. You just called me him. Okay.
I don't know, is it an insult? I can't tell. As I go to the left, I go
Up and down.
down. Now, that's what I was just going to say, Karen. Very good. Notice, the graph goes up for a little, doesn't it? But what are we focusing on? The end. The end. Because it's end behavior. As I go to the right, it goes. So I got, as I go to the right, it goes up. As I go to the left, it goes down. Again, as I go to the right, it goes up. As I go to the left, it goes down. What's your leading coefficient? Which is? Positive. Your degree? Which is? Odd. Next one. As I go to the left, I go?
Negative.
It's all right. As I go to the right, I go?
Yeah.
So as William said, we're going to have, as I go to the right, I go down. As I go to the left, I go up. Again, this is to the right, right is down. This is to the left, left goes up. So what do you notice about your symbols here? They switch. They switch. And that makes sense because look, this graph has a general trend to go up like that, right? Whereas this graph has a trend to go down like that. Now, here's what I want you guys, everybody, to do now. Flip your pages over, back to the front page. Look at the first example of linear functions up here at the top. Look at the first example of linear functions. Look at your answers for end behavior. So look at this region and look at this region for your answers. What do you notice about what's on the board and what's on your paper for the first example? They are the same. They are the same. Really? Andy? Come on. Here, this is the same as like a line. Again, notice the line. I superimposed the line on top of here. When I go to the left, we went down. It's the same for the line, isn't it? And when I go to the right, it goes up. And what do you notice? Look at the degree. Look at the degree for a line and for the one on the board. Aren't they both odd? This is odd right here. This degree, we didn't write it down yet, but the degree was 3, so it was odd. So we can make a generalization about odd functions. If an odd function has a positive coefficient, it looks like this. If an odd function has a negative leading coefficient, like this, -2, it goes down. It looks like this one on the right. Okay, so we'll come back to this in a minute, but just keep that in the back of your mind. Okay? Flip back over. Go to your next example, please. Try and fill this in on your own.
The next two or just the next one?
You can do both of these, yeah.
All right.
You'll see a table at the bottom. In a minute, we'll talk about how to fill in that table. Many of you already got this. I'm going to list the leading coefficients and degrees. Is that outside?
No, it's Melissa farting.
Yeah, that was
You're looking at funny, okay?
Yeah. I was waiting for a response. All right. Look at these graphs, people. What do you notice about them? They both go up here, don't they? And what about here? They both go
down.
What does that make you think of? Like a parabola. Think back to the parabola. Flip your page back over. Parabola was the same thing. A parabola going up looks like this. A parabola going down looks like this. So these even functions also follow a pattern. So we can write here, they're both going up. Here, they're both going down. So, let's go through this now. Here's what I want you all to think about. If a function is even, no matter what it is, if it's x to the 10th power, x to the 12th power, x to the 14th power, no matter what, if it's even, think of a parabola. Think of a parabola. Okay? So if I have a function that looked like this. Okay, this would be, let's see.
Okay, they've all been odd.
This would be x to the 10th right here. But isn't x to the 10th an even function?
Yeah.
Okay? And that follows even rules. Well, that follows the parabola rules. If it's even with a positive coefficient, there's a positive here, we look over here and we think about a parabola going upward. And they both open going upward. It's the same rules. So even functions, think of a parabola. For odd functions, think of a line. Think of the red line that we drew over these graphs here. Okay, so on the next page, what I want to do is write a generalization for these. So for odd and positive, an odd function, we think of a line. A positive line has a positive slope. It goes up like this. So I want you to think about a line like that. For an even positive, we think of a parabola. When a parabola is positive, it opens up. When a parabola is negative, it opens down. So for this one, I want you to think of a shape like that. A smiley face. It's positive. For an odd negative, it goes like this. It's a line aiming like that. And then for even negative, it's a parabola opening down, or a frown. A frown. So here, for this problem, we want to talk about as x goes to infinity. So as the graph goes to the right, what happens? As the graph goes to the left, what happens? So, again, it does not matter what your function is. All that matters is that you know the positive or negative coefficient and even or odd degree. Again, it doesn't matter what the function actually is. So, for this problem, as we go to the right for this line right here in blue, as I go to the right, it has to go up. So this will be positive infinity. As I go to the left, it has to go down. Again, go to the left. To get back to the graph, you got to go down like that. So this one will be negative infinity. What about a quadratic or a parabola?
Positive.
They're both going.
They both
They both
go up.
go up. Both ends of my hand right here, I'm showing you both point upward. So we have positive infinity, positive infinity. for a line that is shaped with a negative leading coefficient? We see that.
Negative.
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 And a positive.
Good, a negative, because as I go to the right, I have to go down,
Positive.
and as I go to the left, I go up.
Positive.
Very good. So it is, as our manual said, positive. And the last one, everybody?
Negative.
Both?
Negative.
Negative.
Okay.
How come they're both negative?
Because it goes down, both.
Very good. They both go down. They both aim down. Think of a parabola, they both go down. Now, what we want to do is go through some example problems. Now, the example problems we're going to go through don't have the graphs. They only have a function listed. There's no graph for these, okay? So, let's look at the next example. So on the next page, which I'm going to hand out to you right now, we're going to look at some examples. These are not your homework. I'll give you homework after. This is the classwork problems I want to work on again.
Mr. House, you have more time now that you make things paper.
Do I what?
You have extra time now.
What do you mean?
Like, you don't get the papers, like, you write it down, but now it's like a lot of papers.
So do I have extra time that I'm making these, you said? I always make these. That's from my headline. So these are the same notes as I have. Except see all these blanks everywhere? See all the blanks? I haven't filled in my notes. So I always type these. So if you ever go on headline, you see all these notes, but they're already filled in.
No.
Oh, we have more time today because I've done it. I knew we'd run out of time, that's why I printed this for you ahead of time. It's a lot of stuff to write down, you know what I mean? All right, so let's take a look. On the next page, you start with this figure. Okay, you start with this figure. It's from your textbook. I copied this figure out. I thought it was a pretty good one. And I usually don't use figures from your textbook, but I like it. Now, this is odd and positive. Let's go back to the table. Where do we see odd and positive, people?
Down there.
The first one, right? Odd, positive. We said use a line like this for odd, positive. Well, let's go back and take a look. To me, that does kind of look like a line. I know it's curved, but it has a line figure to it. For odd and negative, it's also like a line, but it's got a negative slope. For this one, it's even and positive, and it looks like a parabola again. And this one also looks like a parabola. So it says the same thing we just said, but with a figure. Okay, again, it says the exact same information, but with a figure. That's all I wanted to show you there. Now let's look at our examples. Many of you guys all have this on your paper where there's blanks there. I didn't write them down on here. So what I'm going to do is pull open the document so you can see exactly that.
We can do this on our calculator.
You could always graph them and look at the graph, but I want to do it without looking at the graph today. But you could always graph them to check. Okay. So what we want to do here is fill in all of our blanks. Folks, ready?
Yeah.
Here. Oops. Now, all of these parts say x goes to positive infinity. When x goes to positive infinity, we're going to the right. As x goes to negative infinity, for all these parts we're going to fill in, it means it goes to the left. Now, here's what I want to do. Look at the first problem. Look at the first problem. Tell me, what kind of a degree is it? Odd or even?
Even.
It's even. Look at the first one.
It's even.
Even because of the 4.
Oh.
It's even, so it's going to be positive.
And we see that the leading coefficient is positive. So I want you to think to yourself this. Even, positive. That's what I want you to be thinking. Next. If it's even and positive, even makes you think of a parabola. Positive means it opens up. So what do we have on the ends?
Infinity.
Both positives, right? Both positives. None of them are going down. So what I want you to draw now is this. On the right side, please. Please draw that. I know the shape doesn't really look like that because it's x to the 4th, but I want you to draw the general idea. That will tell us that it goes up on the right and it goes up on the left.
And there'll be 2 squigglies.
And yes, there will be a little, this one would look like this.
Yeah.
Yep, that's what it would really look like. Very good.
I saw you counting the things.
1, 2, 3,
Yeah.
4. Very good. You notice that?
Yeah.
We're going to do more and more of that. Yes.
Can we check on the calculator?
You can always check on the calculator. If you plot this in the calculator, you'll see that both ends go off the graph upward. Okay, it might look a little funky in the calculator though, so don't rely on the calculator alone. Are we good on this so far? All right.
Yeah.
Before we get to any more, let's skip down to number 5, please. I'm going to let you do the rest with the partner. Go to number 5.
It's a positive.
Positive and even.
Hey, be careful. Be careful. Is number 5 in the correct order?
No.
The leading coefficient. Ah, tricky. That's what we're going to look at for number 5. So,
Negative even.
this one is negative even. So, we're going down like this. Negative even. Again, take a look. The degree is the highest exponent. Since 4 is the highest exponent, it's even. Its coefficient, though, happens to be negative 2. So this example would be even, negative, which means it's going to open down. Negative infinity, negative infinity. Okay?
There you go.
What do you guys notice, by the way? All the x parts are always the same. See all the x parts that I already wrote for you?
Yeah.
They're always the same. Now, when you do your homework tonight, I'm not going to write any of this stuff. I want you to write this entire statement like this. Okay, for your homework, I want you to write, as x goes to infinity, y goes to whatever. As x goes to negative infinity, y goes to whatever it is. But I want you to write out that entire circled line there during your homework. I put them in here like this just to fill in blanks. One more to look at together. Well, actually, the rest of them I'll let you look at. But again, number 6 is not in the right order. Numbers 2, 3, and 4, take a look and see what you got there. Practice with a partner or work on yourself, either one.
Yeah. It's positive.
Shows the positive infinity components.
If you finish and you get it right, I'll give you homework to get started.
Alright, and then the next one is negative. Negative. Even negative. Are you done recording this out?
Yeah, we're pretty much done recording today. Good stuff. Again, guys, your homework. If you didn't notice, by the way, some of you may have noticed this, I give you a worksheet every night. But I always put down a textbook page in here also.
Alright.
So if you ever want more practice, there's more textbook pages always at the bottom of my notes. So if you ever want to go to the textbook, page 341, 24 to 27, for more practice, if you need it, it's always on there. So take a look. Sometimes I'll just have a worksheet, but I'd say like 9 out of 10 times I put a textbook page there. So you can always do extra work if you need to do more practice.
Alright.
Who's done? If you're done, I'll give you the homework.
Yeah, can you check it out?
Who's who?
That's mine.
His name is second one. Your odd functions are screwed up. Go back and look at number 2, 4, and 6. They're odd functions. You're treating them as a
So it's gonna be negative or is it odd?
When it's an odd function, look at your chart. When it's an odd function and a positive, or odd function and negative, look at your answer. Remember, guys, think of your figures. Think of a line, think of a parabola. Don't rely on the table only. Think of your figures when you're doing this.
Don't rely on the what?
The table.
Why?
Numbers 2, 4, and 6. They're all odd. Look at the highest exponent of 2, 4, and 6. Is that 3? Which is odd. Odd makes me think of a line. Right? And it's positive and odd. So it's odd, but it's positive. So it's going to be infinity and then negative.
Do you want us to write the homework out like this, or do you want us to write the whole?
I want you to write the whole statement on your homework, guys. I want you to do what we did for number 1, please. Write the whole statement out, please. Do not just leave it blank. Write the whole statement.
Yeah, we're just doing it.
I want you to. Every time I want you to draw the shape you're thinking of. Check yours with camera.
Something like this, but. I was all I got it. Awkward. Why would you ever compare?
No, he always does that.
Like shit.
You know what somebody gets?
Oh yeah. Oh yeah, Mr. Howell, look at everything there. No. Which makes me.
He's looking at you guys for the dance and you're
Hey, look, we did it for the night. Ready? No, it's not embarrassing.
Just do it.
You go like this, you just go, this is how we do it.
Look up there. Take a look up there. Ever seen that before? Up on that.
Oh,
Funny you just did that.
figures.
They're all so you have lines, you have there's sine of x, cosine of x, absolute value, a line, a graph.
The way.
Do you want us to